Heat capacity. What is heat capacity? For example, this is a system. So this is a system. So system, for example, system temperature is X temperature. X equal, for example, 27 degrees centigrade. So 27 degrees centigrade or 300 or 300 kelvins. This is X temperature. That's whatever that system has, whatever that gas. So here we have to increase the 1 degree. 1 degree we have to increase the temperature. We are increasing the 1 degree of temperature, whatever that required to observe the energy, required energy to increase the 1 degree of temperature, that is called heat capacity. So here this is a Q, because required energy, heat capacity equal to Q by delta T. Delta T means change in the temperature. So it required whatever that energy to require the substance which increase the 1 degree temperature or 1 degree Kelvin, that is heat capacity. So heat capacity generally we divide into two parts. One more is molar heat capacity. Molar heat capacity. Molar heat capacity. What is molar heat capacity? Same thing. This is a substance. Here 1 mole of substance. 1 mole of substance to increase the 1 degree of temperature, that is called molar heat capacity, that is Cm equal to Q by N into delta T. N is a number of moles. So Q equal to Cm N into Cm into delta T. That is a molar heat capacity. Then one more is a specific heat capacity. Specific heat capacity. Specific heat capacity. Specific heat capacity. So here, that is, what is the specific heat capacity? So here specific heat capacity. Specific heat capacity, here 1 gram of substance. Here we are taking 1 gram of substance to increase the 1 degree of temperature. It requires energy, that is called specific heat capacity. So here specific heat capacity equal to Q by 1 gram M into delta T. M is a mass in grams. Mass in grams. So one is a molar heat capacity, specific heat capacity, then another one is heat capacity. Now we have to find out what is that relationship between the CV and CP. CV and CP. Here in the first case at so C equal to Q by delta T. This is a heat capacity. Then one more is a C equal to Q by N delta T. This is a molar heat capacity. Then one more is a C equal to Q by M into delta T. This one is a specific heat capacity. Specific heat capacity. Specific heat capacity. So in this case, so in adiabatic process, adiabatic means Q equal to 0. What is that specific heat? C equal to Q by delta T. So C equal to 0 by delta T. 0 by something, it is a infinity. Sorry, 0. It is a 0. Means at adiabatic process we cannot measure the heat capacity. In isothermal process means T equal to constant. So delta T equal to 0, C equal to Q by delta T. So C equal to Q by 0. Something by 0. Here infinity. So in this case also we cannot find out the specific heat capacity. One more is you can easily find out either it is in the form of adiabatic process or isochoric process. Okay, in isobaric process means that is a P equal to constant. C equal to QP by delta T. So here QP equal to CP delta T. So it is a P. So here QP means that is always a delta H. Delta H equal to Cp delta T. This is a relationship between the delta. QP means a delta H. Delta H is enthalpy. Enthalpy. Whereas at isochoric process, so Cv equal to Qv delta T. So here QV equal to Cv delta T. So QV means at isochoric process, that is a delta E, internal energy, is equal to Cv into delta T. In this case, here delta E is a internal energy. This is actually enthalpy and again internal energy. One more is what is the relationship between the Cp and Cv? Cv. So what is the relationship between Cp and Cv? So in this case, H equal to E plus Pv. This is a enthalpy formula. So here if ideal gas equation, Pv equal to nRT. So that H equal to E plus nRT. So at 1 mole, H equal to E plus RT. So you have to derive the with respect to temperature. So dt equal to dE by dt equal to R. Because dt cancel, dH by dt means enthalpy. That is generally we are calling as a Cp, because enthalpy, this is a Cv plus or Cp minus Cv equal to R. This is a relationship between Cp and Cv. Thank you.